So today I want us to sketch a hyperbolic function. But before we do that, let's cover some basic aspects. So this is the standard form for a hyperbolic function. You'll say f of x equals a over x plus p. Then you say plus q, like that. So let's go. The value of a is going to tell you about the shape of your function. So how does it tell you the shape? So you need to know that if the value of a is positive, then the terminal arm is going to be in the first quadrant and in the third quadrant. But if your a is negative, the first arm will be in the second quadrant, the other one will be in the fourth quadrant, like that. That's fine. So what about this P? The P is going to tell you about the horizontal shift. By how many units did we shift our function, either to the left or the right? But most importantly, your P is going to tell you the vertical asymptote. So what is this asymptote? An asymptote is a line that a function neither touches nor crosses. So meaning at the asymptote, it's where your function is undefined, where your function does not exist. That's fine. So what about Q? Q is going to tell you the vertical shift. So by how many units did we shift our function, either up or down? But most importantly, it's going to tell you the horizontal asymptote. So these asymptotes, you'll represent them in the form of equations. The same thing applies to the axis of symmetry. So if I want you to write the equation of the horizontal asymptote, you'll just say y equals q, like that. But if I want you to write the equation of the vertical asymptote, you'll start by taking your denominator and equating it to 0, because you understand that at the asymptote, it's where the function is undefined. And you know that one way for a function to be undefined is when the denominator is 0. Division by 0 is undefined. Okay, so from this point, you'll transpose your P to the right. So this becomes the equation of the vertical asymptote. That's fine. So I think this is enough background information for us to make a sketch. So let's go to the real thing. So in order for us to sketch this, we need to know the shape of the function. How is this function going to look like? Then we also need to know the intercepts with the axis, the x and y intercepts. And then we need to know the equations of the asymptotes. So here we can see the value of a is positive, meaning the first arm will be in the first quadrant. The second arm will be in the third quadrant. So we are done with the shape. So let's find the intercept. The easiest intercept to find is the y-intercept. So we know that every time we need to find the y-intercept, we must let x to be 0. So this means we'll have 2, but I see x, I see 0. Then I say plus 3. So 0 minus 2 is negative 2. 2 divided by negative 2 is negative 1. -1 plus 3, it's just going to be +2. But in coordinate form, you'll say where x is 0, y is going to be +2. That's fine. But if I'm looking for the x-intercept, I need to let y to be 0, like that. So we know that f of x is y, right? So where you see f of x, you see y. In this case, you see 0. So it's going to be 2 over x minus 2 plus 3, like that. So when you get to this point, you must solve for x. Well, there are many ways to kill a cat, but the easiest way out in this case is to cross multiply. So if you want to cross multiply, you take the 3 to the left. It becomes negative. But now you realize that the denominator of -3 is actually 1. So then you cross multiply. You say 2 multiplied by 1, it's just going to be 2. And then you say -3 multiplied by x minus 2. So it's going to be something like this, -3 multiplied by x minus 2. So because you are multiplying one term with two terms, you need to distribute. So -3 times x will just be -3x. Then -3 times -2 is a +6. From this point, you take 6 to the left, it becomes negative. 2 minus 6 is -4, like that. Then from this point, you divide both sides by -3. So this means that your x is going to be +4/3. So in coordinate form, it means your x-intercept is going to be 4/3 and 0, like that. So you have found both of your intercepts. That's fine. But now what if you must find the asymptotes? So the easiest asymptote to find is the horizontal asymptote. So what is the equation of the horizontal asymptote? It's y equals q. But q in this case will just be 3. But we said if you must find the vertical asymptote, you take the denominator, you equate it to 0. Then you solve for x. So x equals 2, it's just the equation of your vertical asymptote. Then what is remaining is to make a sketch. So let's get rid of everything here. Not really everything, part of everything. So if you must make a sketch, I think the first thing you must put is your asymptotes. So let's go. We'll use different colors for asymptotes, but it's okay if you use one color. You are consistent. So we said the vertical asymptote, the equation is x equals 2, meaning it's going to cut x at 2. Think of that. It's going to cut the x-axis at 2. That's the meaning. X equals 2. So after doing your dotted line like this, you will label it and tell us that it's going to be the vertical asymptote. That's how you tell us. Okay, that's fine. But you said to me the horizontal asymptote, it's going to be y equals +3, like that. That's fine. I think I might want to extrapolate the y-axis a bit, but let's say this is going to be y equals 3, like that. Yes, let's extend the y-axis a bit. more or less. So it means we must also extend the vertical asymptote. Okay. So after this, then we need to plot our intercepts. So we said the y-intercept is going to be at positive 2 there. And then we said the x-intercept is going to be at 4/3, which is roughly 1.33. So it's less than 2. That's fine. You label your axis like that. Show us this is the y-axis, and this one is the x-axis. So what did we say? We said the value of A is positive. We are expecting the first arm to be here, the second arm to be there. So this is how it's going to look like. Like that. So let's assume it's a nice thing there. Yeah, more or less, we tried. Okay. And then the second arm is just going to be like that. Perfect. So you need to make sure that your arms do not touch the asymptote. Because it's an asymptote, it can't touch the asymptote. But now there's going to be a fault here. It's not really a fault, but you observe that the arm in the first quadrant, it doesn't really have a point on it, right? It can be. So you must make sure that it has at least one point. It can't be an arm that is lying without a point. So what point are you going to put there? It's going to be your decision. So let's go to the calculator and substitute any value of x that is greater than 2 into the original equation. So if we substitute 3, for instance, you say 2 divided by 3 minus 2, and then you say plus 3. Then we find a y value of 5. So what is the meaning? It means when x is 3, for instance, y is going to be 5. So you need to make sure that both arms, they have a point on them. So if one of the arms doesn't have a point, you choose any value of x you prefer, then you substitute it into the original equation to find the corresponding y value. It's now a point, so you plot it on your graph. Okay. Now, there's something I want to say while we are still at it. This is enough. If you did this, it's more than enough for an examiner to be convinced and to be happy. But I want to add something. So you need to know that this hyperbolic function, it has two axes of symmetry. So we said an axis of symmetry is a line that cuts the graph into two equal parts. You need to know that. So we have an axis of symmetry with a positive gradient. Listen to that. So let's show you. So how is the axis of symmetry with a positive gradient going to look like? So this is how it's going to look like. Because you can see that this straight line is sloping upwards to the right. So because it's going up, then we know that it has a positive gradient. But it's also going to be the other one with a negative gradient. So this is how it's going to look like. like that. Perfect. So I want to tell you something that is very important. These axes of symmetry, they are going to pass through this point. So what is this point? It is the point of intersection of your two asymptotes. So it's where the horizontal asymptote and the vertical asymptote intersect. So at that point of intersection, that's where your two lines, in fact, your two axes of symmetry or lines of symmetry are going to pass through. So you must know that. Now, in the exam, the examiner is going to say, write down the equation of an axis of symmetry or the equation of a line of symmetry with a positive gradient. He can either say with a positive gradient or with a negative gradient. So this is the good news. If he says with a positive gradient, then the gradient is going to be positive 1. That's what you must know. If he says with a negative gradient, the gradient is going to be negative 1. It doesn't change. It's always like that. So let's find the line of symmetry with a positive gradient, its equation. Of course, you'll do your golden arrows to show it's a straight line. It's forever continuing. So we know that it's a straight line, so we must use this form, y equals mx plus c. But we are looking for the line of symmetry with a positive gradient, so the gradient is exactly 1. Then for x, we are going to substitute the point of intersection of the two asymptotes. So we can see that the asymptotes intersect when x is 2 and y is going to be 3. So 2 and 3 is the point of intersection. That's fine. So you'll come here and say that point is going to be 2, the x value there, and then you say plus c, but the y value is going to be 3. So 1 times 2 is 2. You want to solve for c, so you take 2 to the left. So you realize the value of c is going to be 1. So this means the equation of the line of symmetry with a positive gradient is going to be x plus 1. So you can come and label it like that. But if you must find the equation of the line of symmetry with a negative gradient, then you know the gradient is negative 1. So you'll still use the form y equals mx plus c, but then you say the gradient is negative 1, and the x value there is going to be 2. We are still looking for c once again, but the y value is positive 3. So negative 1 times 2 is going to be negative 2. Taking it to the left, it becomes positive. So 3 plus 2 is going to be 5, meaning the value of c is going to be 5. So this means the equation of the line of symmetry with a negative gradient is just going to be y equals negative x plus 5. So you come and plug it in there. So this is the most important thing. If the examiner didn't talk about the lines of symmetry for a hyperbolic function, you don't talk about them. You don't show them on the sketch. You don't calculate anything. But if he asks you something about it, then you're going to answer him. Of course, you tell him or her everything I've told you. And when you do that, you're going to be fine. You'll never go wrong. You have my word. Okay, yes, I think that's it for this one. Yes, I think that's it for this one. But of course, you need to label your hyperbolic function and tell them it's going to be f, like that. So let's look at another one. So what if I ask you to sketch this one for me? So firstly, we said we need to know the shape. So we see the negative here. So if you have negative 2 over x, you should know that this negative belongs to the numerator. So it's like you're having negative 2 over x. So with that being said, it means the negative in front is actually for 3. So now that we know the value of a is negative, we are expecting the first arm to be in the second quadrant and the second arm in the fourth quadrant. So we know the shape. That's fine. Now we need to find the intercepts. So we said the easiest is the y-intercept. But every time we need to find the y-intercept, we must let x to be 0. So you'll say y equals negative 3 over 0 plus 2. And then you say minus 1 like that. So if you plug it into your calculator, you just get negative 5 over 2. But in coordinate form, you'll say where x is 0, y is negative 2.5, like that. Then next we find the x-intercept. But if we need to find the x-intercept, we must let y to be 0. That's fine. So every time you see g of x, you see y, and where you see y, you put 0. Then from this point, we want to solve for x. So let's take negative 1 to the left. When it gets to the left, it becomes positive. And then let's take this negative and give it to the numerator. So it's negative 3 over x plus 2. But of course, you understand that the denominator of 1 is actually 1. So at this point, we cross multiply. Negative 3 times 1 is just going to be negative 3. And then 1 times x plus 2 is going to remain x plus 2. Then you take this 2 to the left, it becomes negative. Negative 3 minus 2 will just be negative 5. So this is your x-intercept. But in coordinate form, you'll say where x is negative 5, y is going to be 0. That's fine. But if I want you to tell me the equation of the horizontal asymptote, you'll say y equals q. And q in this case, it's just going to be negative 1. But if you must find the vertical asymptote, you take the denominator and equate it to 0. So then your x will just be negative 2, like that. So you have everything you need to make a sketch. So let's go ahead and sketch this function. We'll use different colors here as well. But we said the best way is to start by plotting your asymptotes. So you'll tell them the vertical asymptote is where x is going to be negative 2, like that. So you'll tell them x equals negative 2 is the vertical asymptote. What about the horizontal asymptote? So it's y equals negative 1. something like that. Then you just label it and tell them y equals -1 like that. That's fine. Of course, you must label your x's. Otherwise, they might deduct few marks from that. Okay, that's fine. Then we should plot our intercepts. So we said the y-intercept is at -2.5. So if this is 1, then maybe the y-intercept will be here. Okay, what about the x-intercept? We said it's going to be at -5. So maybe somewhere there. I think we might want to extrapolate our x-axis a bit. So let's do that. More or less. So one thing we said is that the first arm must be in the second quadrant. And then the other arm will be in the fourth quadrant. So we are expecting a situation like this one. It's an ugly graph. So let's try to make it a little bit handsome. So your function will approach the asymptote, but it must never touch the asymptote. Like that. Yes, I think it's much better. So you'll say where x is 0, y is -2.5, like that. And then here, let's just make sure the point is on the graph. Yes, so when you get here, you'll say where x is -5, y is going to be 0. The name of this function is going to be g of x, like that. And then we said this is the vertical asymptote. So the equation is x equals -2, like that. And if you did this, they are more than happy in the exam. You get all your marks. So once again, what if the examiner says, tell us the equation of the axis of symmetry with a positive gradient as well as a negative gradient? And sometimes the examiner can say, sketch those lines of symmetry on your function, on the same system of axes, or on the same set of axes. So how do you do that? Easy enough. So we know we are going to have an axis of symmetry with a positive gradient, but remember we said it's going to pass through the point of intersection of the two asymptotes. Remember that. And if you have a look at this red line, you can see that it's actually dividing your graph into two equal parts. So it's not really a line, but it won't pass directly at the origin. It might pass at the origin, well, it might not sometimes. But in most cases, it can pass through the origin. Yeah, it can pass through the origin, but not always the case. No, it's not necessarily true. It's a matter of sometimes. That's if the y-intercept of that line is going to be 0. So let's see first in our calculations. Yes, we should see in our calculations. And I think previously we didn't really take that into account. We just made a sketch of those lines of symmetry without checking their y-intercepts. So we'll rectify that mistake here. Okay, so what color should we use? Well, let's try to use maybe dark blue will do. So if I say that, then it's not wise to start by sketching the lines of symmetry. No, it's not really wise. Let's start by finding the equations first. Okay. So we are looking for the line of symmetry with a positive gradient, right? That's fine. We said the gradient is going to be positive 1. That's fine. So what about the x value? So we can see that this point is the point of intersection of the two asymptotes. So at that point, the x value is going to be -2, and then the y value is going to be -1, like that. So 1 times -2 is -2. Taking it to the left, it becomes positive. -1 plus 2, it's going to be +1. So this means the y-intercept is going to be 1, implying that the equation of this line of symmetry is going to be y equals x plus 1, like that. That's fine. So we now know the y-intercept is going to be 1. So meaning if we must sketch this line of symmetry, this is how it's supposed to look like. It's supposed to cut the y-axis. Yes, more or less. More or less. So if you did this, they are convinced because they can see that it's going through the y-axis. So it has a y-intercept. Perfect. Meaning it doesn't really go through the origin. Okay. So let's go and find the equation of the line of symmetry with a negative gradient. And we must also sketch it. So here we said the gradient will be exactly -1. So what about the x value? The x value is still -2, and then the y value is going to be -1. So -1 times -2 is a +2. Then you take this +2 to the left, it becomes negative. So -1 minus 2, it's -3. So this means the value of C is just going to be -3. So this means the equation will simply be -x minus 3. So what is the meaning here? It means this line of symmetry is going to have a y-intercept at -3. So I'm supposed to have something that is more or less like this. More or less. Because we can see that if this is -2.5, then that one can be -3. So as long as they can see that the y-intercept is going to be less than -2.5, yes, you are good to go. It doesn't necessarily have to go through the origin. That's the concept I'm trying to preach. Okay, so if you did this, they are more than happy in the exam. So